Hello, in this lecture we will find out the length of line segment MN. In the drawing we have square ABCD. We know that one side of square ABCD is equal to 12 units, that is to say AB equals to BC equals to CD equals to DA equals to 12 units. Inside this square we have a circle. The center of this circle is at point M, and we also have a semicircle. The center of this semicircle is at point N, and we want to find out the distance between the center of the circle, that is to say point M, and the center of the semicircle, that is to say point M. Or we want to find out the length of line segment MN. Okay, so first of all we will define the point of tendency of tangent AB with this circle as point P. We will define the point of tendency of tangent BC with this circle as point Q. We will define the point of tendency of diagonal AC or tangent AC with this circle as point R. And we will define the point of tendency of tangent AC with this semicircle as point S, and we will define the touching point of the semicircle with side DC as point T, and we will also define the length of line segment PB as A. That is to say, PB equals to A according to our definition. So actually, what is the length of AP? You can see it from the drawing. It is very easy to see that the length of line segment AP, it is actually equals to AB minus PB. That is to say AP equals to AB, that is 12 units, minus PB, that is A. So in conclusion, we found out that AP equals to 12 minus A. In the next step, I will present to you a new rule that is actually rule number 1. According to rule number 1, the lengths of two tangents from a common external point. To a circle are equal. We'll read rule number 1 again. According to rule number 1, the lengths of two tangents from a common external point to a circle are equal. So what is the meaning of rule number 1? The meaning of rule number 1 is that if we have an external point P, here point P is an external point in relation to this circle, because point P is not located inside this circle nor on this circle, but it is located outside this circle. Therefore point P is defined as an external point in relation to this circle. So if from the external point P we draw two tangents to this circle, then the first tangent, this will be the first tangent, we define the point of tendency of the first tangent if the circle is point A, and then we draw second tangent from point P to this circle. We define the point of tendency of the second tangent with this circle as point B, and according to rule number 1, the lengths of two tangents, that is to say the length of the first tangent is PA and the length of the second tangent is PB. And according to rule number 1, the lengths of two tangents from a common external point, that is to say from point P to a circle, 2 points A and B, are equal. That is to say, according to rule number 1, PA is equal to PB. So whenever you draw two tangents to a circle from a common external point, then the length of those two tangents will be equal to each other. In this case, PA equals to PB. Okay? So here we can implement rule number 1 in our drawing. We will focus on the external point B, from the external point B, this point, we have two tangents to this circle. The first tangent is tangent BP, and the second tangent is tangent BQ. And according to rule number 1, the lengths of those two tangents are equal to each other. That is to say, BP is equal to BQ according to rule number 1. But according to our definition, BP equals to A. So we can write here BP equals to A. And from this equation, A equals to BP equals to BQ, we will derive that BQ is also equal to A. BQ equals to A. So we can write here that BQ equals to A. And what is the length of QC? So from the drawing, it is very easy to see that QC equals to BC minus BQ. I'll repeat again. QC equals to BC minus BQ. So QC is equal to BC, that is 12 units, minus BQ, that is A. So in conclusion, we found out that QC is also equals to 12 minus A, like AP. In the next step, we will focus on the external point, point A. From the external point, point A, we have two tangents to this circle. The first tangent is tangent AP, and the second tangent is tangent AR. And according to rule number 1, the lengths of those two tangents are equal to each other. That is to say, AP is equal to AR. But we have already found out that AP is equal to 12 minus A. Here AP equals to 12 minus A. And from this equation, 12 minus A equals to AP equals to AR, we will derive that AR is also equal to 12 minus A. So we can write here that AR equals to 12 minus A. We will continue to focus on the external point, point A. From the external point, point A, we have two tangents to the semicircle. The first tangent is tangent AD, and the second tangent is tangent AS. Tangent AS is tangent to the semicircle at point S, and tangent AD is tangent to the semicircle at point D. And according to rule number 1, the lengths of those two tangents are equal to each other. That is to say, AD equals to AS. But it is given us in the question that AD equals to 12 units. You know from the question itself that AD equals to 12 units because all of the sides of the square are equal to each other. That is to say, all of its sides are equal to 12 units. So here from this equation 12 equals to AD equals to AS, we will derive that AS is also equals to 12 units. So we can write here that AS is equal to 12 units. In the next step, we will focus on the external point C. Here, from the external point C, we have two tangents to this circle. The first tangent is tangent CQ, and the second tangent to this circle is tangent CR. And according to rule number 1, the length of tangent CQ must be equal to the length of tangent CR because they exited from the same external point C. But we have already found out that CQ equals to 12 minus A. CQ equals to 12 minus A. CQ equals to 12 minus A. So from this equation 12 minus A equals to CQ equals to CR, we will conclude that CR is also equals to 12 minus A. So we can write here that CR is equal to 12 minus A. And what is the length of RS? It is very easy to see from the drawing that the length of line segment RS, it is actually equals to AS minus AR. And repeat again, from the drawing it is very easy to see that the length of line segment RS is equal to AS minus AR. So RS, the length of this line segment, is equal to AS, that is 12 units, minus AR, that is 12 minus A. So RS equals to 12, we will open the brackets here, 12 minus 12 is 0, minus and minus is plus. So in conclusion, we found out that RS equals to A. So we can write here that RS equals to A units. And what is the length of SC? The length of line segment SC It is very easy to see from the drawing that SC is equal to RC minus RS. I will repeat again, the length of line segment SC is equal to RC minus RS. So SC is equal to RC, that is 12 minus A, as you can see here, minus RS, that is A. So in conclusion, we found out that SC is equal to 12 minus A is minus 12A. So SC is equal to 12 minus 2A. You can write here that line segment SC is equal to 12 minus 2A. And what is the length of diagonal AC? The length of diagonal AC it is very easy to see that the length of diagonal AC is equal to AR plus RC. So AC equals to AR plus RC. AR is equal to 12 minus A, and RC is also equals to 12 minus A. In conclusion, we found out that AC equals to 12 plus 12 is 24. Minus A is minus 2A. Minus A plus minus A is minus 2A. So in conclusion, we found out that the length of the diagonal AC is equal to 24 minus 2A. In the next step, I will present to you a new rule that will be rule number 2. According to rule number 2, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. I will read rule number 2 again. According to rule number 2, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So what is the meaning of rule number 2? The meaning of rule number 2 is that if we have this circle, and we know that the center of this circle is at this point, point O, and we also have here tangent AB. Tangent AB is tangent to this circle at this point. We define the point of tendency as point M. So I write it down that M is the point of tendency of tangent AB with this circle. We'll join points O and M together by a straight line. Here OM is the radius of this circle, therefore we'll define it as R. And the reason that OM is the radius of this circle is because of the fact that line segment OM starts from the center of this circle, that is to say from point O, and ends at point M, that is the point on this circle itself. Therefore, line segment OM is the radius of this circle, therefore we defined it as R. So here we have the radius OM that is drawn to the point of tendency. That is to say, it is drawn to point M, that is the point of tendency of tangent AB with this circle, and whenever you have a radius that is drawn to the point of tendency, then the tangent will be perpendicular to the radius. In this case, the tangent AB will be perpendicular to the radius MO. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. Again, according to rule number 2, a tangent to a circle, that is to say tangent AB, is perpendicular to the radius drawn to its point of tendency. So whenever you have a radius, like in this drawing, radius OM that is drawn to the point of tendency, you can see here that the radius OM, it is drawn to the point of tendency. That is to say, it is drawn to point M, that is the point of tendency of tangent AB with this circle. Then the tangent will be perpendicular to the radius. In this case, the tangent AB will be perpendicular to the radius MO. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. And we can implement rule number 2 in our drawing. We'll join points M and P together by a straight line. Here, line segment MP is the radius of this circle because of the fact that it starts from the center of this circle and ends at point P, that is the point of this circle itself. Therefore, MP is the radius of this circle, and the radius MP, it is drawn to the point of tendency. That is to say, it is drawn to point P, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is drawn to the point of tendency, then the tangent will be perpendicular to the radius. In this case, the tangent AB will be perpendicular to the radius PM. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. Okay? And We know that all the angles inside the square are right angles, therefore angle ABC will be equal to 90 degrees because it is 1 out of 4 angles inside square ABCD, therefore it is a right angle. In the next step, we will join points M and Q together by a straight line. Line segment MQ is the radius of this circle because of the fact that line segment MQ starts from the center of this circle, that is to say from point M, and ends at point Q, that is a point on this circle itself. Therefore, MQ is the radius of this circle, and we have the radius MQ that is drawn to the point of tendency, that is to say it is drawn to point Q, that is the point of tendency of tangent BC with this circle. And whenever you have a radius that is drawn to the point of tendency, then the tangent will be perpendicular to the radius. In this case, the tangent BC will be perpendicular to the radius QM. That is to say, this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. So actually in quadrilateral PBMQ, we have 1, 2, 3 right angles. The sum of 3 right angles is 90 times 3 is 270 degrees, plus the size of the fourth angle, that is actually angle PMQ. So in total, the sum of those 4 angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. I will repeat again. The sum of the 3 angles, that is 270 degrees, plus the size of the fourth angle, that is actually angle PMQ. In total, they must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. We'll subtract 270 degrees from this equation, and we get that angle PMQ, the missing angle, is equal to 360 degrees minus 270 degrees. It is 90 degrees. So we actually found out that angle PQ is a right angle equal to 90 degrees. Therefore, quadrilateral PBMQ has 4 right angles, and any quadrilateral that has 4 right angles must be at least a rectangle. So I write it down that quadrilateral PBMQ that has 4 right angles must be at least a rectangle, if not a square. I'll repeat again. Quadrilateral PBMQ that has 4 right angles must be at least a rectangle, if not a square. So we actually have rule number 3. According to rule number 3, the opposite sides of a rectangle are equal to each other. I will read rule number 3 again. According to rule number 3, the opposite sides of a rectangle are equal to each other. So the opposite sides of rectangle PB and Q are equal to each other. That is to say, PB is equal to MQ. According to rule number 3. I repeat again, PB equals to MQ according to rule number 3. But we have already, according to our definition, PB equals to A. So from this equation, A equals to PB equals to MQ, we will derive that MQ is also equals to A. MQ equals to A, that is to say, the radius of the circle is equal to A units. Likewise, according to rule number 3, BQ is equal to PM. Here, BQ equals to PM according to rule number 3. But we have already found out that BQ equals to A. So from this equation, A equals to BQ equals to PM, we will derive that PM is also equals to A. PM is also equals to A. So we actually found out that quadrilateral PBMQ is a square. Why? Because all of its sides are equal to each other. They are equal to A. Quadrilateral PBMQ is not a rectangle but a square. Okay. In the next step, we will focus on the right triangle ABC, and we will implement the Pythagoras theorem on the right triangle ABC. So, according to Pythagoras theorem, if the letters PT is abbreviation for Pythagoras theorem, so in the right triangle ABC, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, the hypotenuse is AC, the square of the hypotenuse is AC square, and it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to AB square plus BC square. I repeat again, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars in the right triangle ABC. That is to say, AC square equals to AB square plus BC square. Okay? But we have only found out that AC equals to 24 minus 2A. Therefore, AC squared will be equal to 24 minus 2A squared. And it is equal to AB squared. AB is 12, so AB squared is 12 squared. Plus BC squared. BC is also equals to 12, so BC squared will be also equal to 12 squared. So according to equation number 1, 24 minus 2A squared equals to 12 squared plus 12 squared is 2 times 12 squared. Here we take out of this equation number 1, and we get that according to equation number 1, 24 minus 2A equals to the square root of 2 times 12. Why 12? Because the square root of 12 is 12. The square root of 12 square, here, the square root of 12 square is 12 because of the fact that the root cancels the square and we left only with 12. Okay? Here we will add to this equation 2A, and then we will subtract square root of 2 times 12 from this equation number 1, and we will get that 2A equals to 24 minus square root of 2 times 12. We divide equation number 1 by 2, and we get that according to equation number 1, A equals to 24 over 2 is 12, minus 12 over 2 is minus 6, times square root of 2. So in conclusion, we found out that A, that is actually the radius of the circle, is equal to 12 minus 6 times square root of 2 units. In the next step, we will define the radius of this semicircle as B. Here, DN, line segment DN, is the radius of this semicircle. Why? Because of the fact that line segment DN starts from the center of this semicircle, that is to say from point N, and ends at point D, that is a point on this semicircle itself. Therefore, dn is the radius of this semicircle, that is to say, it will be equal to B according to our definition. Because according to our definition, the radius of this semicircle is equal to B. Likewise, line segment NT is also the radius of this semicircle because of the fact that it starts from point N, that is the center of this semicircle, and ends at point D, that is a point on this semicircle itself. Therefore, the NT is the radius of this semicircle, that is to say, it equals to B. And what is the value of line segment TC? You can see it is very easy to see from the drawing that the value of the length of line segment TC, it is actually equals to DC minus dn minus nt. Again, dc minus dn minus nt equals to tc. So tc equals to dc minus dn minus nt. I repeat again. Tc equals to dc minus dn minus 20. So TC equals to DC equals to 12 units. It is one side of square ABCD minus dn, that is B, minus nt, that is also B. So in conclusion, we found out that TC equals to 12 minus 2B. TC equals to 12 minus 2B. So we can write here that TC equals to 12 minus 2B. In the next step, we join points N and S together by a straight line. The length NS, it is actually the radius of this semicircle. Why? Because of the fact that line segment NS starts from the center of this semicircle, that is to say from point N, and ends at point S, that is a point on this semicircle itself. Therefore, NS is the radius of this semicircle, that is to say it equals to B units. So, actually we know that the radius NS of this semicircle, it is drawn to the point of tendency, that is to say, it is drawn to point S, that is the point of tendency of tangent AC with this semicircle. And whenever you have a radius that is drawn to the point of tendency, then the tangent will be perpendicular to the radius. In this case, the tangent AC will be perpendicular to the radius SN. That is to say, so AC is perpendicular to SN. That is to say, this angle equals to 90 degrees, and this angle will be also equal to 90 degrees. And because of the fact that angle NSC is equal to 90 degrees, then triangle NSC, the green triangle, is a right triangle. So, what is the length of SC, or the length of the hypotenuse NC of the green right triangle? Here you can see it from the drawing that the hypotenuse NC of the green right triangle, triangle NCS, the hypotenuse NC is equal to NT plus TC. Again, NC equals to NT plus TC. NT equals to B. And TC equals to 12 minus 2B. So in conclusion, we actually found out that the hypotenuse NC equals to 12, and B minus 2B is minus B. In conclusion, we found out that the hypotenuse NC of the green right triangle, triangle NCS, equals to 12 minus B. So we can write here that NC the hypotenuse of the green right triangle equals to 12 minus B. In the next step, we will implement the Pythagoras theorem on the green right triangle, triangle NCS. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars, that is to say NC square will be equal to NS square plus SC square. So I'll repeat again. Here in the right triangle NCS, by PT's Pythagoras theorem, abbreviation for Pythagoras theorem, NC square equals to NS square plus SC square. And we already found out that NC is equal to 2F minus B, so NC square will be equal to 2F minus B square. That equals to NS square. NS is equal to B, so NS square will be equal to B square plus SC square. SC is equal to 12 minus A, so SC square will be equal, SC equals to 12 minus 2A, so SC square will be equal to 12 minus 2A square. I will repeat again, according to equation number 2, 12 minus B square equals to B square plus 12 minus 2A square. Here we will find out the value of the expression 12 minus 2A. Twelve minus 2A is equal to 12 minus 2 times A, and we already found out that A equals to 12 minus 6 times square root of 2 units. So we will get here that it equals to 12 minus 2 times 12 is minus 24 minus 2 times minus 6 is plus 12 times square root of 2 . So we have here 12 times square root of 2. 12 minus 24 is minus 12. So in conclusion, we found out that 12 minus 2A is equal to 12 times square root of 2 minus 12. Again, I repeat again, 12 minus 2A equals to 12 times square root of 2 minus 12, so we can substitute 12 minus 2A in equation number 2 by 12 times square root of 2 minus 12. We'll do it now and we'll get that according to equation number 2. Twelve minus B square is equal to 12 square plus B square minus 2 times 12 times B, and it equals to B square plus 12 minus 2A is equals to 12 minus square root of 2 minus 12, so we will substitute 12 minus 2A in equation number 2 by 12 times square root of 2 minus 12 square so according to equation number 2, 12 square Here we have b squared on both sides of the equation, so b squared will get cancelled, and we left with 12 squared minus 2 minus 12b is minus 24b. That equals to, here we have 12 times 2 of 2 minus 12, so we'll take 12 as a common factor out of this expression, so we'll have here 12. What is left from 12 times square root of 2 after we took 12 as a common factor? What is left is actually square root of 2. And what is left from minus 12 after we took 12 from it as a common factor? What is left is actually minus 1 all squared. So according to equation number 2, 12 squared minus 24b is equal to, here we have 12 times square root of 2 minus 1 squared, and according to the algebraic identity that x times y to the power of m is equal to the x to the power of m times y to the power of m. According to this trigonometric identity, 12 times square root of 2 minus 1 squared will be equal to 12 squared times square root of 2 minus 1 squared. Okay? So according to equation number 2, we get that 12 squared minus 24b equals to 12 squared, and square root of 2 minus 1 squared is equal to square root of 2 squared, that is 2, plus 1 squared, that is 1, minus 2 times square root of 2 times 1. Okay, so according to equation number 2, twelve squared minus 24b is equal, we'll open the brackets here, and we'll get that 12 squared times 2 is equal to 2 times 12 squared plus 1 times 12 squared minus 2 times square root of 2 times 12 squared. Here we have 12 squared on both sides of the equation, so 12 squared will get cancelled. And what is left on equation number 2 after we cancel 12 squared? What is left? It is actually in this side we have minus 24b equals to 2 times 12 squared. 12 squared is 144. 144 times 2 is 288. Here we have 12 squared times minus 2. 12 squared is 144 times minus 2 is minus 288 times square root of 2. Here we will divide equation number 2 by 24, and we will get that according to equation number 2, minus 24b over 24 is minus b. that equals to 288 over 24 is 12. And minus 288 over 24 is minus 12 times square root of 2. Here we multiply equation number 2 by minus 1. And we get it according to equation number 2. We found out that b equals to 12 times square root of 2 minus 12. Okay. B, that is actually the radius of the semicircle, equals to 12 times root of 2 minus 12. And we have already found out that A is equal to 12 minus 6 times root of 2 units. Is the radius of the circle. And what is the value of A plus B? The value of A plus B, it is very easy to see from those two expressions that A plus B equals to, we have here minus 12 plus 12 is 0, and 12 times square root of 2 minus 6 times square root of 2 is equal to 6 times square root of 2 units. So in conclusion, we found out that A plus B equals to 6 times square root of 2 units. So in the next step, we will join points M and R together by a straight line. Line segment MR is the radius of this circle because of the fact that line segment MR starts from the center of this circle, that is to say from point M, and ends at point R, that is a point of this circle itself. Therefore, this is exactly the definition of a radius. Rm is the radius of this circle, that is to say it equals to A units. In the next step, from the center, from point M, we will go perpendicular on Rm. From the center M of this circle, we will go perpendicular on Rm. So this angle will be equal to 90 degrees according to our construction. In the next step, we will extend NS, that is actually the radius of the semicircle that equals to B units. We will extend NS until it intersects with the perpendicular from point M. And we will define the intersection point of the extended NS and the perpendicular from point M as X. Okay. So here we created quadrilateral RMXS. But before that, we have the radius MR. The radius MR of this circle, it is drawn to the point of tendency. That is to say, it is drawn to point R, that is the point of tendency of tangent AC with this circle. And whenever you have a radius that is drawn to the point of tendency, then the tangent will be perpendicular to the radius. That is to say, the tangent, in this case, the tangent AC will be perpendicular to the radius Rm. So AC is perpendicular to Rm, that is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. And this is the second perpendicular, according to our construction, angle RMX is also equals to 90 degrees. And here we have NS is the radius of the semicircle. That is to say, it equals to B, and it is the radius of the semicircle, and as a radius it is absolutely a straight line. NS as a radius, it is absolutely a straight line. And when we extended the straight line NS by a straight line, we got NX. So NX is the result of extending NX is the result of extending NS by straight line. And whenever you extend a straight line by a straight line, the result must be a straight line. So when we extended the straight line NS by a straight line, we got NX, that it is still must be a straight line. So we can write down that NX is a straight line. Again, when you extend a straight line by a straight line, the result must be a straight line. So when we extended the straight line NS by a straight line and we got line segment NX, NX must be also a straight line. So I will write it down that line segment NX is a straight line. Line segment NX is a straight line, and we have also rule number 4. It states that the sum of the angles on one side of a straight line is equal to 180 degrees. I read rule number 4 again. According to rule number 4, the sum of the angles on one side of a straight line is equal to 180 degrees. So here, if we found out that NX is a straight line, and if we focus on the upper side of the straight line NX at point S, then according to rule number 4, the sum of its angles at point S must be equal to 180 degrees. So which angles we have on the upper side of NX at point S? We have here 90 degrees plus angle RSX. In total, the sum of those two angles must be equal to 180 degrees. So 90 degrees plus the size of angle RSX. In total, the sum of those two angles must be equal to 180 degrees, according to rule number 4. Here we'll subtract 90 degrees from this equation, and we get that the size of angle RSX is equal to 180 degrees minus 90 degrees is 90 degrees. So we found out that angle RSX is a right angle, it equals to 90 degrees. Angle RSX is a right angle, So actually, in quadrilateral RMSX, we have three right angles, 1, 2, 3, and the sum of three right angles is 270 degrees. So 270 degrees plus the size of angle MXS. In total, those four angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. I repeat again, the sum of three angles, that is 270 degrees, plus the size of the fourth angle, that is the actual angle MXS. In total, they must be equal to 360 degrees. We will subtract 270 degrees from this equation, and we get that the size of angle MXS is actually equal to 360 degrees minus 270 degrees is 90 degrees. So we found out that the fourth angle MXS, is also equal to 90 degrees. So we can write here that angle MXS is equal to 90 degrees. So we actually found out that all the angles inside quadrilateral RMSX are right angles. It has four right angles, and any quadrilateral that has four right angles must be at least a rectangle. So we can write down that quadrilateral RMSX that has four right angles must be at least a rectangle, if not a square. I repeat again, quadrilateral RMSX that is four right angles must be at least a rectangle, if not a square. And according to rule number 3, the opposite sides of a rectangle are equal to each other. So in rectangle RMSX, RM must be equal to SX. I repeat again, according to rule number 3, RM must be equal to SX. According to rule number 3, that states that the opposite sides of a rectangle are equal to each other, RM must be equal to SX. But RM equals to A, it is the radius of the circle. So we can write here that RM equals to A, and from this equation A equals to RM equals to SX, we will derive that SX is also equals to A. So we can write here that SX is also equals to A. Likewise, according to rule number 3, MX must be equal to RS, or RS equals to MX. According to rule number 3, I repeat again, according to rule number 3, RS equals to MX, but we have already found out that RS equals to A. Here RS equals to A. From this equation A equals to RS equals to MX, we will derive that MX is also equals to A. MX is also equals to A. MX equals to A. So we actually found out that quadrilateral RMSX is not a rectangle but a square, because of the fact that all of its sides are equal to each other, they are equal to A units. And because of the fact that angle MXN is a right angle, therefore triangle MXN is a right angle. The orange triangle MXN is a right triangle, therefore we can implement the Pythagoras theorem on the orange right triangle MXN. So according to the Pythagoras theorem, in the right orange triangle MXN, so in the right orange triangle MXN, by PT, by Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is Mn, so the square of the hypotenuse is Mn square. And it must be equal to the sum of the squares of the perpendiculars, that is to say, it must be equal to mx square plus nx square. Again, according to Pythagoras theorem, mn square equals to mx square plus nx square in the right triangle, the right orange triangle mxn. So mx is a, so mx square is a square plus nx. nx is a plus b, so nx square is a plus b square. And it equals to mn square. I repeat again, according to equation number 3, a square plus a plus b square equals to mn square. We have already found out that a equals to 12 minus 6 times square root of 2. So a square will be equal to 12 minus 6 times square root of 2 square plus a plus b square. We have already found out that a plus b is equal to 6 times square root of 2. Therefore a plus b square will be equal to 6 times square root of 2 square. And it equals to the square of the hypotenuse, that is actually mn square. Here, 12 minus 6 times square root of 2 square is equal to 12 square plus 6 times square root of 2 square. 6 times square root of 2 square is 6 squared, that is 36, times square root of 2 squared, that is 2, and 36 times 2 is 72, minus 2 times 12 times 6 times square root of 2, and plus 6 times square root of 2 square. We only found out that 6 times square root of 2 square is 72, and it equals to mn square. So according to equation number 2, here we have 72 plus 72 is 144, and 12 square is also 144. 144 plus 144 is 2 times 144. minus 2 times 6 is minus 12, minus 12 times 12 is minus 144 times square root of 2, and it is equal to mn squared. Here we'll take 144 as a common factor out of those two expressions, and we'll get that, so 144 is a common factor. What is left from 2 times 144 after we took from it 2 as a common factor? What is left? It's actually 2, and what is left from minus 144 times square root of 2 after we took from it 144 as a common factor? What is left? It is actually minus square root of 2, and it equals to mn squared. Here we take a root out of this equation, equation number 3, and you will get that the square root of 144 is 12 times the square root of 2 minus square root of 2. It is equal to mn. Okay, so actually we found out that mn, that is the distance between the centers of the semicircle and the circle, is equal to either 12 times square root of 2 minus square root of 2, or in terms of numbers it equals to 9.18 units. I repeat again, the answer to the question is that the distance between the centers of the semicircle and the circle, that is to say the length of line segment mn, it is actually either 12 times square root of 2 times 2 minus square root of 2 units, or in terms of numbers it equals to 9.18 units. In the next step I will summarize the lecture. Here we have square ABCD. We know that one side of this square is equal to 12 units. Inside this square we have semicircle and circle. The center of the semicircle is at this point, point N. The center of this circle is at point M. And we want to find out the distance between their centers. That is to say the length of line segment MN. So, first of all, we define the point of tendency of tangent AB with this circle as point P. We define the point of tendency of tangent BC with this circle as point Q. We define the point of tendency of tangent AC with this circle as point R. We define the point of tendency of tangent AC with the semicircle as point S, and we define the touching point of the semicircle with side DC as point T. Then we define PB as A, that is to say PB equals to A according to our definition. What is the value of AP? Here AP, it is very easy to see that AP equals to AB minus PB. AP equals to AB minus PB, but AB equals to 12 units. PB equals to A according to our definition, so in conclusion, we found out that AP is equal to 12 minus A. AP equals to 12 minus A. Then I presented to you rule number 1. According to rule number 1, the lengths of two tangents from a common external point to a circle are equal. So what is the meaning of rule number 1? The meaning of rule number 1 is that if we have this circle and point P, this is point P, that is a common external point. It is an external point. Why point P is an external point? Because point P is not located inside this circle, nor on this circle, but it is located outside of this circle. Therefore, point P is defined as an external point, and if from the external point, point P, we draw two tangents to this circle, the first tangent is tangent PA, the point of tangency of the first tangent with this circle is point A. Then we draw a second tangent, tangent PB, the point of tangency of the second tangent with this circle is at point B. Then according to rule number 1, the lengths of two tangents, that is to say, the length of the first tangent is PA and the length of the second tangent is PB. So the length of two tangents from a common external point, the common external point is point P, to a circle, that is to say to points A and B, are equal. So whenever you draw two tangents to a circle from a common external point, in this case the common external point, point P, then the lengths of those two tangents will be equal to each other. That is to say, PA will be equal to PB. Okay? So we can implement rule number 1 in our drawing, because in our drawing we have the external point, point B. From the external point, point B, we have two tangents to this circle. The first tangent is tangent BP, the second tangent is tangent BQ, and according to rule number 1, the lengths of those two tangents will be equal to each other. That is to say, BP is equal to BQ. Here, BP equals to BQ according to rule number 1, but according to our definition, BP is equal to A. So from this equation, A equals to BP equals to BQ, we will derive that BQ is also equals to A. Here BQ is also equals to A. And what is the value of, what is the length of line segment QC? The length of line segment QC will be equal to BC minus BQ. The length of line segment QC equals to BC minus BQ, but BC equals to 12, BQ equals to A, so in conclusion we found out that QC equals to 12 minus A. Then we focus at point A. From point A we have two tangents to this circle. From the external point, point A, we have two tangents to this circle. The first tangent is tangent AB and the second tangent is tangent AR. And according to rule number 1, the lengths of those two tangents will be equal to each other. That is to say, AP is equal to AR according to rule number 1. But we have already found out that AP equals to 12 minus A. So from this equation, 12 minus A equals to AP equals to AR, we will conclude that AR is also equals to 12 minus A. So we can write here that AR is equal to 12 minus A. We continue to focus on the external point, point A. From the external point, point A, we have two tangents to the semicircle. The first tangent is tangent AD, the second tangent is tangent AS. And according to rule number 1, the lengths of those two tangents will be equal to each other. That is to say, AD equals to AS according to rule number 1, but AD equals to 12 units. It is one side of square ABCD. AD equals to 12 units. So from this equation, 12 equals to AD equals to AS, we will derive that AS is also equals to 12 units. Here AS is equal to 12 units. Then we focus on the external point C. From the external point C, we have two tangents to this circle. The first tangent is tangent CQ. The second tangent is tangent CR. And according to rule number 1, they must be equal to each other. Here, CQ must be equal to CR. CQ must be equal to CR according to rule number 1. But we have already found out that CQ equals to 2F minus A. So from this equation 2F minus A equals to CQ equals to CR, we will derive that CR is also equals to 2F minus A. Here CR is equals to 2F minus A. And what is the value of RS? The value of line segment RS, it is very easy to see from the drawing that RS equals to RC minus RS equals to RC minus SC. RS equals to, here RS equals to AS minus AR. I repeat again, the length of line segment RS is equal to AS minus AR. I repeat again, the length of line segment RS equals to AS minus AR, but AS equals to 12 units, AR equals to 12 minus A, so in conclusion we found out that RS equals to 12 minus 12 minus A. We open the brackets and we got that Rx equals to 12 minus 12 plus A. 12 minus 12 is 0. So in conclusion we found out that Rs equals to A. And then we found out the value of line segment SC. What is the value of line segment SC? The value of the length of line segment SC, it will be equal to RC minus RS. Again, SC is equal to RC minus RS. So SC equals to RC, that is 12 minus A, minus RS, that is A. So in conclusion, we found out that SC equals to 12 minus A minus A. 12 minus A minus A is equal to 12 minus 2A. So here, in conclusion, we found out that SC equals to 12 minus 2A. Then I presented to you rule number 2, according, and before that we have what is the length of diagonal AC. The length of diagonal AC, it is actually equals to AR plus RC. Again, AC equals to AR plus RC. But AR equals to 12 minus A and RC is also equals to 12 minus A. So in conclusion, we found out that AC equals to 12 plus 12, that is 24. And minus A plus minus A is minus 2A. So in conclusion, we found out that the length of diagonal AC is equal to 24 minus 2A. Then I presented to you rule number 2. According to rule number 2, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So what is the meaning of rule number 2? The meaning of rule number 2 is that if we have this circle and the center of this circle is at this point O, and we have also tangent AB to this circle. Tangent AB is tangent to this circle at point M. Point M is the point of tendency of tangent AB with this circle. OM is the radius of this circle because of the fact that it starts from the center of the circle and ends at point M, that is the point of this circle itself. Therefore, OM is the radius of this circle. So we defined OM as R. Abbreviation for radius. So we have here the radius OM that is drawn to the point of tendency. That is to say, it is drawn to point M, that is the point of tendency of tangent AB with this circle. And whenever we have a radius that is drawn to the point of tendency, then the tangent will be perpendicular to that radius. In this case, the tangent AB will be perpendicular to the radius MO. AB perpendicular to MO, that is to say, this angle equals 90 degrees, and this angle will be also equal to 90 degrees. This is rule number 2. Here we implemented rule number 2 in our drawing. We joined points M and P together by a straight line. MP is the radius of this circle because of the fact that it starts from the center of the circle, that is to say from point M, and ends at point P, that is the point on this circle itself. Therefore MP is the radius of this circle. We have the radius of this circle, MP, that is drawn to the point of tendency, that is to say it is drawn to point P, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is drawn to the point of tendency, then the tangent will be perpendicular to the radius. In this case, the tangent AB will be perpendicular to the radius PM. So the tangent AB will be perpendicular to the radius PM. So AB is perpendicular to PM, that is to say this angle equals 90 degrees, and this angle will be also equal to 90 degrees. And we have the rule that the sum of the angles, we know that all the angles inside the square are right angles, so angle ABC, that is 1 out of 4 angles inside square ABCD, must be equal to 90 degrees. So angle ABC equals to 90 degrees. Then we join points M and Q together by a straight line. Again, MQ is the radius of this circle because of the fact that it starts from the center of the circle, that is to say from point M, and ends at point Q, that is the point on this circle itself. Therefore MQ is the radius of this circle. Okay, and we have the radius MQ that is drawn to the point of tendency, that is to say it is drawn to point Q, that is the point of tendency of tangent BC with this circle. And whenever we have a radius that is drawn to the point of tendency, then the tangent will be perpendicular to that radius. In this case, the tangent BC will be perpendicular to the radius QM. So BC is perpendicular to QM. This is to say this angle equals 90 degrees, and this angle will also equal to 90 degrees. So actually, quadrilateral PBMQ has 1, 2, 3 right angles, and the sum of 3 right angles is 270 degrees. 270 degrees plus the size of the fourth angle, that is actually angle PMQ. In total, they must be equal to 360 degrees. 270 degrees plus the size of the fourth angle PMQ must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. We subtracted 270 degrees from this equation and found out that the missing angle PMQ is equal to 90 degrees. So this angle equals to 90 degrees. Therefore, in quadrilateral PBMQ we have 4 right angles, and any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So we can write down that quadrilateral PBMQ that has 4 right angles must be at least a rectangle, if not a square. Then I presented to you rule number 3. According to rule number 3, the opposite sides of a rectangle are equal to each other. That is to say, the opposite sides of rectangle PBMQ are equal to each other. That is to say, PB is equal to MQ. According to rule number 3, PB equals to MQ. But according to our definition, PB equals to A. So from this equation, A equals to PB equals to MQ, we derive that MQ is also equals to A. Here MQ equals to A, so MQ is the radius of this circle, and the radius of this circle is equal to A. Likewise, BQ is equal to PM according to rule number 3. BQ equals to PM according to rule number 3. But we already found out that BQ equals to A, so from this equation A equals to BQ equals to PM, we derive that PM is also equals to A. PM is also equals to A, so we found out that quadrilateral PBMQ is not a rectangle but a square because of the fact that all of its sides are equal to each other, they are equal to A. So quadrilateral PBMQ is a square. Then we implemented the Pythagoras theorem on the right triangle, triangle ABC. According to the Pythagoras theorem on the right triangle, triangle ABC, the square of the hypotenuse equals to the sum of the squares of the perpendiculars, that is to say AC square must be equal to AB square plus BC square, AC square must be equal to AB square plus BC square. We have already found out that AC equals to 24 minus 2A, so AC square is 24 minus 2A square, and it equals to AB square. AB is 12, so AB square is 12 square plus BC square. BC is also 12, so BC square will be also equal to 12 square. So we got that according to equation number 1, 24 minus 2A square equals to 12 square plus 12 square is 2 times 12 square. Okay. Here we took a root out of this equation, equation number 1, and we got that 24 minus 2A equals to the square root of 2 times 12. Why times 12? Because the square root of 12 square is 12. Why? Because the root cancels the square, and we left only with 12, so according to equation number 1, we found out that 24 minus 2A equals to the square root of 2 times 12. Here we added to this equation 2A and we subtracted square root of 2 minus 12. And we got that according to equation number 1, 2A equals to 24 minus square root of 2 times 12. We divided this equation number 1 by 2, and we got that A, that is the radius of the circle, is equal to 12, because 24 over 2 is 12, and minus 12 over 2 is minus 6. So in conclusion, we found out that A, that is the radius of the circle, is equal to 12 minus 6 times square root of 2 units. Then we defined this, the radius of the semicircle as B, therefore dN is equal to B and NT is also equal to B. They are both the radiuses of the semicircle. And what is the value of TC? TC will be equal to DC minus DN minus NT. Here TC equals to DC minus DN minus TC, so TC equals to DC, that is 12, minus DN, that is B, minus TN, that is also B. So in conclusion, we found out that TC equals to 12 minus B minus B, 12 minus B minus B is 12 minus 2B. So we found out that in conclusion that TC equals to 12 minus 2B, so we can write here that TC equals to 12 minus 2B. Then we found out the value of NC, the value of the hypotenuse NC of the main triangle. NC is equal to NT plus TC. NC equals to NT plus TC. So NC equals to NT, that is B, plus TC, that is 12 minus 2B. So NC equals to 12, and B minus 2B is minus B. So in conclusion, we found out that NC, the hypotenuse of the main triangle, equals to 12 minus B. So actually, in the next step, we we join together points N and S2 by a straight line. NS is the radius of the semicircle, that is to say it equals to B. And we have the radius NS that is known to the point of tendency, that is to say it is known to point S, that is the point of tendency of tangent AC with this semicircle. And whenever you have a radius that is known to the point of tendency, then the tangent will be perpendicular to that radius. In this case, the tangent AC will be perpendicular to the radius SN. So AC is perpendicular to SN, that is to say this angle equals 90 degrees, and this angle will be also equal to 90 degrees. And because of the fact that angle NSC is equal to 90 degrees, then the green triangle NSC is a right triangle, so we can implement the Pythagoras theorem on the green right triangle NSC. And according to the Pythagoras theorem on the green right triangle NSC, NC square equals to NS square plus SC square. The square of the hypotenuse is NC square is equal to NS square plus SC square. We have already found out that NC is equal to 12 minus b, so NC square is 12 minus b square. NS is the radius of the semicircle, therefore NS square is b square. SC is 12 minus a, so SC square is 12 minus 2a square. So in the next step we found the value of the expression 12 minus 2a. 12 minus 2a equals to 12 minus 2 times a. And a, we have already found out that a equals to 12 minus 6 times square root of 2. So we open the brackets here and we got that this expression equals to 12 minus 2 times 12 is minus 24, and minus 2 times minus 6 is plus 12, so in conclusion we found out that it equals to 12 minus 24 plus 12 times square root of 2, so it is 12 times square root of 2, and 12 minus 24 is minus 12, so in conclusion we found out that 12 minus 2a equals to 12 times square root of 2 minus 12. So we can substitute 12 minus 2a in this equation number 2, by 12 times square root of 2 minus 12. We did it, and we got that according to equation number 2, 12 minus b square equals to 12 square plus b square minus 2 times 12 times b, that equals to b square, and we substituted 12 minus 2a by 12 times square root of 2 minus 12 square according to this equation. We have b square on both sides of the equation, so b square is cancelled, and what is left after we cancelled b square from equation number 2, what is left is actually 12 square, and minus 2 times minus 12 is minus 24, so here we have minus 24b, that equals to 12 times square root of 2 minus, so here we have 12 times square root of 2 minus 12. We took 12 as a common factor out of this expression, and inside the brackets we have square root of 2 minus 1. Then we have here 12 square minus 24b is equal to this expression. We calculated the value of this expression according to the algebraic identity that states that xy to the power of m is equal to x to the power of m times y to the power of m. So according to this algebraic identity, the value of this expression will be equal to 12 square times square root of 2 minus 1 square. So according to equation number 2, we got that 12 square minus 24b equals to, here we calculated the value of square root of 2 minus 1 square. Square root of 2 minus 1 square equals to square root of 2 square, that is 2, plus 1 square, that is also square root of 2 minus 1 square equals to square root of 2 square, that is 2, plus 1 square, that is 1, minus 2 times square root of 2 times 1. Then we open the brackets here, and we got that 12 square minus 24b equals to 2 times 12 square plus 1 times 12 square minus 2 times square root of 2 times 12 square. Here we have 12 square on both sides of the equation, so 12 square will get cancelled. What is left from equation number 2 after we cancel 12 square? What is left? It is actually this side of the equation number 2. We have minus 24b, and here we have 12 squared is 144. 144 times 2 is 288. And we have here minus 2 times 12 squared is minus 2 times 144, that is minus 288 times square root of 2. We divided the equation number 2 by 24, and we got that minus 24b over 24 is minus b. 288 over 12 is 288 over 24 is 12, and minus 288 over 24 is minus 12. So the conclusion we got that minus b equals to 12 minus 12 times square root of 2. We multiplied the equation number 2 by minus 1, and we got that the value of b, that is the radius of the semicircle, is equal to 12 times square root of 2 minus 12. And we have already found out that a equals to 12 minus 6 times square root of 2 units. What is the value of a plus b here? It is very easy to see that a plus b equals to, here we have 12 plus minus 12 is 0, and 12 times square root of 2 minus 6 times square root of 2 is 6 times square root of 2. So in conclusion, we found out that a plus b equals to 6 times square root of 2 units. Then we joined points M and R together by a straight line. MR is the radius of this circle, that is to say it equals to A. And we have here the radius MR, it is drawn to the point of tendency. That is to say it is drawn to point R, that is the point of tendency of tangent AC with this circle. And whenever we have a radius that is drawn to the point of tendency, like in this drawing, then the tangent will be perpendicular to this radius. In this case, the tangent AC will be perpendicular to the radius RM. So AC is perpendicular to RM, that is to say this angle equals to 90 degrees, and this angle will be also equal to 90 degrees according to rule number 2. Then we did the construction from the center point M. We draw perpendicular on RM, so this angle equals to 90 degrees. And then we extended the radius NS until it intersects with the perpendicular from point M. We define the intersection point of the extended NS and the perpendicular from point M as X. So we have here quadrilateral RM as X, but here we know that NS is the radius of the semicircle, therefore it is absolutely a straight line. And when we extended the straight line NS by straight line, we got a straight line. That is to say, we got line segment NX, that it is still must be a straight line. Because when you extend a straight line by a straight line, it must be still a straight line. So NX is a straight line. We know that NX, line segment NX is a straight line, and we have rule number 4 that states that the sum of the angles on one side of a straight line is equal to 180 degrees. So we know that NX is a straight line. So if we focus on the upper side of the straight line NX at point S, this point, then the sum of the angles here must be equal to 180 degrees. So which angles we have here? At point S we have 90 degrees plus angle RSX. In total the sum of those two angles must be equal to 180 degrees according to rule number 4. 90 degrees plus the size of angle RSX must be equal to 180 degrees according to rule number 4. We subtracted 90 degrees from this equation, and we got that angle RSX equals to 90 degrees. So this angle RSX equals to 90 degrees, So we have here 1, 2, 3 right angles in quadrilateral RMSX. In quadrilateral RMSX we have 3 right angles, and the sum of 3 right angles is 270 degrees. So 270 degrees plus the size of the fourth angle, that is actually angle MXS, in total they must be equal to 360 degrees. again 270 degrees plus the size of the fourth angle that is actually angle MXX. In total, they must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. We subtracted 270 degrees from this equation and we got that the value of the fourth angle that is actually MXS is equal to 90 degrees. This angle equals to 90 degrees, so actually we found out that in quadrilateral RMSX we have 4 right angles. And any quadrilateral that has 4 right angles must be at least a rectangle. Okay, quadrilateral RMSX that has 4 right angles must be at least a rectangle. And according to rule number 3, the opposite sides of a rectangle are equal to each other. That is to say, in rectangle RMSX, RM must be equal to SX. RM must be equal to SX according to rule number 3. But we have already found out that RM equals to A. It is the radius of the circle. So from this equation, A equals to RM equals to SX, we will derive that SX is also equals to A. Here Sx is also equals to A. Likewise, Rs must be equal to Mx in quadrilateral RMSX. In rectangle RMSX, Rs must be equal to Mx. Rs must be equal to Mx according to rule number 3, that the opposite sides of a rectangle are equal to each other. But we have already found out that Rs equals to A. So from this equation, A equals to Rs equals to Mx, we will derive that Mx is also equals to A. Here Mx is also equals to A. So we actually found out that quadrilateral RMSX is not a rectangle but a square. And because of the fact that angle MXN is equal to 90 degrees, then triangle MXN is a right triangle. So we can implement the Pythagoras theorem on the right orange triangle, triangle MXN. According to the Pythagoras theorem, in the orange right triangle, triangle MXN, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, mn square equals to mx square plus nx square. Here mx equals to a, so mx square is a square. Nx is equals to a plus b, so nx square is a plus b square. We have already found out that a equals to 12 minus 6 times square root of 2, so a square is 12 minus 6 times square root of 2 square. A plus b, we have already found out that a plus b equals to 6 times square root of 2, so a plus b square will be equal to 6 times square root of 2 square. Here we open the brackets and we got that 12 minus 6 times square root of 2 square is equal to 12 square, and 6 times square root of 2 square is 72, minus 2 times 12 times 6 times square root of 2, and we already found out that 6 times square root of 2 square is 72, and it equals to mn square. Here we have 12 square we have here 12 square, that is 144, plus 72 plus 72 is also 144. 144 plus 144 is 2 times 144, and we have here also 12 times 6 times 2, 6 times minus 2 is minus 12, minus 12 times minus 12 is minus 144. So in conclusion, we found out that according to equation number 3, 2 times 144 minus 144 times square root of 2 equals to mn square. We took a root out of this equation, equation number 3, and we got that the square root of 144 is 12, and times the square root of 2 minus square root of 2. So in conclusion, we found out that mn, that is the distance between the center of the semicircle and the center of the circle, the length mn is equal to either 12 times square root of 2 minus square root of 2 units, or in terms of numbers, it equals to 9.18 units. I repeat again, the distance between the center of the semicircle, that is point N, and the center of this circle, that is point M, or the length of MN, is equal to either 12 times square root of 2 times square root of 2 square root of 2 minus square root of 2 units, or in terms of numbers, it equals to 9.18 units. Okay, thank you very much.